welcome everybody to another episode of our Puget Systems live Q&A show. This one is actually really cool. I say this a lot, but I'm really excited as usual because we have Chris Hall down in the corner there, Director of Software Development for AMD, straight from the source. We're going to be talking about Threadripper and Threadripper Pro in general, but also taking questions and stuff from the audience as well. We're also joined by Matt Bach, our internal sort of content creation expert, and Kelly Shipman, our 3D design, VFX, probably just 3D stuff.
3D
expert.
Stuff, game dev, yeah.
Yeah. So, Chris, go ahead and give yourself a little introduction, who you are and what you do.
Yeah, thanks, Houston. So, Chris Hall, I work here at AMD. I run a team here called Software Performance Engineering, actually, and there are lots of performance engineers at AMD, but most of those engineers are focused on improving the performance of the products. We really focus on improving the performance of software that runs on top of our products. And as part of that, we work on things from entry-level Chromebooks, the sort of thing that my daughter has in her school, all the way up to Threadripper and Threadripper Pro. So we get to see a wide span of performance. And I have to say, the most exciting thing about Threadripper Pro is it's given us the chance to work with some really cool customers and really see the things that people can do with our products. You know, we're nerds. You know, AMD is a company full of nerds. We get excited about the technology itself, but it's a completely different thing to see somebody take what you've built and use it to create something incredible, something you can't even imagine how to do. That's really the best part about my job.
And I imagine you probably have to do quite a bit with companies like Adobe and Unreal and all those guys, because AMD, like, you guys have always had like such high core counts, and software being able to utilize those higher core counts sometimes is very difficult. So I'm sure you guys have to do a lot of working with them to help them just develop their software to be able to take advantage of it.
Yeah, no, something we like to point out even to ourselves occasionally is, if you think back 4 years ago, 5 years ago, 4 cores in a CPU was considered to be pretty extreme, right? And here we are in 2021, you get 64 cores in a Threadripper Pro. So 4 or 5 years ago, the software companies, when they're thinking about their roadmap or thinking about, hey, is our software correctly tuned for these sort of workloads, for these sort of CPUs, they didn't even have access to the sort of CPU that would enable them even to test what was going on. And the other thing that happened when we introduced 64-core Threadripper, the world had never seen a desktop CPU of 64 cores. And honestly, there was a lot of software that needed some tweaks to accommodate that and scale up. So when we get prototypes in, when we get the earliest samples inside, one of the things we start doing is looking across the applications and saying, okay, what do we need to go change? Because we have this runway, the product going to launch a year from now. There's going to be something, because there'll be some application that's never seen this level of performance before, and we need to go and adjust that. And it varies by workload. I think there are some workloads that take video encoding, right? So video encoding with H.264, which has been the old standard, just the nature of the H.264 format means at some point you don't get scalability on cores. On the other hand, H.265, AV1, those higher end, newer codecs, they lend themselves to that sort of power. And that's one of the other things in our involvement with our software partners, is really to say, hey, by the way, this is the sort of performance we've got coming, right? Or this is the performance we're going to launch 6 months from now. What are the things that you wish you could do for your customers you can't do today because you don't have enough power? Things you wouldn't even consider, but now you've got 64 cores. Now you can consider doing it. Now you can go solve problems for your customers that they've been dying to solve. They just needed the right processor to come along.
So you must get involved like all the way up the stack to OS and driver level stuff, and then also with the software companies?
Yeah, we get involved really with every part. So parts of AMD, we're involved with Microsoft and thinking about how the OS scheduler works with the higher core counts. Drivers is one you say, well, does that really matter? Well, the answer is yes, right? There are things you can do in a driver to take advantage of core counts. In fact, show my age here, but if we go back to the mid late 90s, there was a company called Dynamic Pictures that was acquired by 3D Labs. They had a geometry accelerator for the GPU, and they were using the CPU and the GPU together to do the geometry acceleration. So they were taking advantage of cores then to increase the geometry throughput for 3D graphics, right?
Wow.
So you can use those cores in all sorts of different places. And then, of course, the applications themselves. And sometimes it's about non-obvious ways. One of the things that we did in the past year, for example, is we work with Blender. In Blender rendering, there's actually a portion of a rendering process when you start up, when you're building these structures that it allows the rendering itself to happen. And that portion, and the data transfer from core Blender into the rendering part of Blender, that was all single threaded. So we went and worked with Blender Foundation and said, hey, let's make some changes here and start using the cores here as well. And it's not that it couldn't be done before, but sometimes parallelizing those processes, you need enough cores to make it worth it, right? If you only had 2 cores, if you only have 4 cores, yes, you could do the parallelizing, but you might only get 5% more or 10% more performance. But when you do that work and now you bring 64 cores to the party, all of a sudden the benefit is there, the users are happy, everybody's happy really. And the other thing that I like about this business too, it's not always about speed. One of the things about Threadripper and Threadripper Pro that we found with our customers is you've got this extra power, your deadline didn't move, right? Instead, what you get is you get to iterate more often on your workload, you get to refine your workload, you get to use that power to give you more time to do a better job. So I like to think about it as our products and the way that they've started to be used across the visual effects industry. They're one of the things that are enabling people to take visual effects to another level, right? They have the time because they have the power to just do things better.
Well, and some of it too, like this is one area that I'm hoping we can improve on in the future in our own performance testing is when you have more cores than you need. That just means that there are now cores available to do other things. We do all of our performance testing. Most people do their performance testing in okay, we're going to test Premiere Pro, and that's what we benchmark because you want a clean results. But in reality, people have Premiere Pro and After Effects and Photoshop and 5,000 Chrome tabs, open, and that's what reality is. And so, yes, the fact that say Premiere Pro, maybe you don't see a big performance benefit above 32 cores, but that's just Premiere Pro. When you have, 32 cores,
and it might just be that one operation that you're doing in Premiere Pro. Yeah, we've seen this effect. And in fact, we saw it. One of the things we did with Threadripper 3 is we took, from my lab actually, we took some systems and put them in place with Blur Studios while they were working on the latest Terminator movie that came out. And, the guy running the studio said that the first way he could tell who had the Threadripper 3 that day is they were always looking at their screen. Other people, they would do an operation and now they can't do anything else because their computer has been consumed by this batch job or this render that they're doing. But the people with Threadripper 3, Threadripper Pro, you can kick off that workload and then go do something else entirely and still be productive. And I experienced it myself recently. We did a video together with our friends at Boris FX and a couple of very talented artists for Adobe Max, the conference. And we were in the middle of recording that video, and this is all live. And they pulled up, they were doing some work in Cinema 4D, and then they clicked and did a batch operation, and they pulled up Unreal Engine and they were doing an export. And then they just turned around and opened up After Effects. And they didn't think twice about doing that. In fact, these guys, they've had Threadripper Pro with them so long, it's become second nature to them, but they just know, I just start and do the next thing that I want to do. And I think that's the hidden secret to high core count processors is it's that power. It's always there when you need it. And the people who have these as their tools, they just have the confidence that whatever it is they need to do at any moment in time, they can just do it. The power is always there on tap.
Well, and it's not just the CPU power too. It's like the RAM capacity. Because if you want to run multiple applications, you're going to need more RAM. And Threadripper does 128. Threadripper Pro is it 512? I don't know. It's stuff you don't got to worry about it.
Threadripper Pro, if you can find the DIMMs, you can put a terabyte of memory in a Threadripper Pro.
Okay.
You know, now you've got to have a pretty healthy budget to afford to do that.
Yeah.
But I think it's also true that the people who are trying to do things that need a terabyte of memory, you know, that they're trying to do things that you can only do if you do that. So yes, it is about having the memory capacity. It's also about the rest of the chip as well, right? So it's not just the memory capacity. Threadripper Pro has 8 channels of memory, and that gives it a tremendous amount of memory bandwidth. And that's important to feed the CPU, especially if you're looking at simulation workloads. You know, Houdini is a classic example of that. You know, if you want to do high-end simulations in Houdini, you need memory bandwidth, and that's where Threadripper Pro really excels. But then it's more than just that, because then you say, oh, that's just the CPU. But imagine you have 3 high-end graphics cards in there that you're using to run a machine learning training workload. You know, the thing that nobody really likes to talk about in machine learning training is you have to feed the beast. You have to feed those graphics cards. So you need a chip like Threadripper Pro that can just keep those graphics cards busy. Otherwise, they're just waiting on the system to deliver them the next piece of data to work on. So it's all of those. Having core counts alone is not enough, right? And that's why we don't sell 64 core processors with only 2 channels of memory. It just doesn't make sense. It might make sense for some cases. You know, actually, a good example of that is Cinebench, right? So Cinebench is a famous benchmark. We use it a lot at AMD. We use it a lot to predict our performance. But the reality is, Cinebench only needs a certain amount of memory bandwidth. And once you have enough memory bandwidth, you can start scaling up your cores. You can have a very unbalanced system and still have a very healthy Cinebench score. When you start looking outside of that one piece of the production pipeline, you find that you need the memory bandwidth as well. And it's really important not to just look at one metric when you're evaluating your system. I think you guys do a great job of really helping customers and users focus on thinking about the workload that they're doing. And you can see for yourselves, I'm sure, across the benchmarks that you run, whether it's the ones that you publish or the ones you use internally, that different applications have different performance profiles. The thing that Threadripper Pro does is it has a lot of everything, and that really helps.
Yeah, that's one of the things I really liked about the 3000 series Threadripper. Kind of started this, but it comes to the Threadripper Pro too. Is that was the generation where single core performance took a huge jump. Like it went way up. Because before that, you were kind of in a weird situation sometimes. Okay, you do really lightly threaded stuff, you'd go Ryzen. If you were highly threaded stuff, you'd go Threadripper. But, a lot of people don't do just one or the other. Like they use Photoshop and Premiere Pro, and those are very different. But with the current gen, like Threadripper and Threadripper Pro, what I really enjoy is that they're really good for single threaded applications too. So you can have the best in both worlds. And then also, like expanding on that, the other thing I like about Threadripper Pro in particular is it almost seems like you don't have to think about whether the platform's going to be capable of something. Like it allows 512 or a terabyte of RAM. So like, yeah, it's enough RAM for like almost anybody. Same with like PCIe lanes. It has 128 PCIe lanes. Like, you're fine. Don't worry about it.
Yeah, and the Threadripper Pro comes with all of the pro features, the manageability, and the extra security that you'd expect for an enterprise class application. But you're right, with Threadripper 3 and Threadripper Pro, we really took that leap where you don't have to sacrifice single-threaded performance. That's not to say that for certain specific workloads, you couldn't find a desktop processor like a Ryzen 5950X that has the higher single-thread performance for that one thing that you're trying to do. But Threadripper Pro has more than enough single-threaded performance for most people who are not trying to achieve 500 frames a second in League of Legends or something like that on the gaming side. And the best example for that is, Threadripper Pro has always been, and Threadripper, they've always been good for the back end of production. But with Threadripper 3, Threadripper Pro, the other thing they became very good for is virtual production, because they have enough single-threaded performance to drive the graphics cards. You can go drive your render wall, or you can go drive your virtual production backdrop LED wall with a Threadripper Pro, because it has more than enough single-threaded performance. It's so so much single thread performance when you're driving 4K displays, when you're not trying to hit incredible high-end frame rates. You've got enough. And then the great thing there is when the director says, hang on a minute, I need to move that light in the scene over here, and you have to go back in Unreal and rebake your lighting. Well, you had the single threaded performance, and now you have 64 cores to go do that light baking operation really quickly as well, right? And that's the thing.
Right.
Threadripper Pro it's excellent at everything, and it does what you need when you need it.
Because usually, if you sorry, go ahead, go.
So that's why I've been in my Unreal Engine benchmarks, my articles I do, that I've been debating on including FPS for CPU testing at all, because like I keep including it because I can show that if you're doing like 1080p with all the special effects turned off, then yeah, there's a difference in CPUs. But once you go up to 4K and start having ray tracing on and stuff, like there's no difference between a Threadripper and a Ryzen, like, or an Intel. Like they're all going to be chugging along the same because it's not an issue.
Yeah, I think that is one of the challenges, Kelly, is we're always looking for benchmarks and performance measures that show us the best of every component in the system. But sometimes when you go hunting for that metric that shows the differentiation, you start down a path that makes no sense for a real user, right?
Yeah.
And for gamers, for esports gamers, absolutely hundreds of frames a second, that really matters to them, right? And they will sacrifice a lot just to get an extra 10 frames a second, because that could be the difference between, virtual life and virtual death. But for professionals who are working with their systems, especially those who by themselves are only making content at 60 frames a second, or maybe they're making content at 120 frames a second. Once you hit that level, now it's perhaps not so much about how much extra performance you have, but how much power are you consuming while you deliver that performance. And that's, I think, an area we're going to start to see as a tipping point in this industry. Is in some cases, in some workloads, you have enough performance. Well, turns out the artists are just going to turn around and throw more polygons in, or throw 10 times the number of particles, and they'll absolutely do that. But then the other thing that comes in here is how much power are you consuming? You certainly don't want to be consuming so much power that you need to have an electrician come and put specialty power at your desk, right? And Threadripper Pro, 280 watts, 64 cores. Look at all that performance. It's really at the sweet spot. It's hard to imagine we would think about a 500 watt Threadripper Pro, right? Because clearly we could design something like that, and it would run hot, and it would run even faster in the multi-threaded workloads. But it wouldn't be very useful. It certainly wouldn't be good as a desk side workstation. Most people wouldn't enjoy that. They'd rather have that balance and say, no, I don't want extreme cooling, because of course Threadripper Pro, you can do it with a very nice air cooler. You don't need liquid cooling to reach the performance that we deliver. That's really important to a lot of our customers, whether they are having a unit on set in a rack in a trolley that they bring onto the virtual set, or whether they're putting it in a data center where they're and they're doing Workstation as a data center item, and they have a limit on their cooling envelope and their power per cubic inch in that data center. There's a balancing act, and that's the part that we try. I think we've done a very good job of hitting that balance point and delivering the right products, but with power consumption that makes sense.
Yeah.
Well, because it's probably worth pointing out that like power consumption isn't just like, how many dollars you're gonna have to spend on electricity a month or whatever. It's also power is directly related to noise. Like you put a watt of power in, it's going to make a watt of heat, and so lower power draw to get the same job done also just means your system's going to be quieter. And I mean that's something we've focused on for a very long time, is keeping the systems quiet and cool at the same time. And man, like you hear like people who, they go from something that sounded like a jet engine to now they don't even hear it. They need to see the LED, the power LED has to be there, otherwise they won't know it's on. And like that just like totally changes, I think, people's workflows. It's the kind of thing where, you hear a sound forever. It kind of, you get used to it. But then once it goes away, it's just like freeing. And especially when you're doing, you know, things on set, like you say, like with all the virtual production stuff now, they have to bring quite a bit of horsepower in, but like they still have to record audio and, you know, and all that kind of stuff.
Mhm.
Like it can't have lots of noise.
Yeah.
Or, you know, at home, you know, it seems like, you know, with, you know, the whole YouTube, you know, stuff that's, you know, just blowing up, like there's more and more content creators making their own videos and doing voiceovers and, you know, all that, and being able to do all of that without having the system noise is a huge deal.
Yeah.
Like,
Oh,
it was,
never mind the system noise. What about your air conditioning bills in the summer, right? Oh,
Sure.
you know, the old story was of, oh my God, I've got to turn on my workstation and it's July and it's 90 degrees outside,
Yep.
and all of a sudden I'm getting pretty toasty in my room. That's the other effect, right? The whole work from home thing has really changed the way that people think about their systems as well. And it's not just
Absolutely.
the noise and the heat, but the other thing that you get with Threadripper Pro is you get it in a pretty compact package, you know, considering what it's got in it, right?
Mhm.
You know, before Threadripper Pro, you really had to have a dual socket workstation, and those things were monsters, and these
Yeah.
monster sized chassis. Frankly, you almost needed two people to lift them and move them into your room. And Threadripper Pro brings that all in. And let's not forget that, yes, you can have a 64 core Threadripper Pro, but if your budget doesn't allow it, or maybe you're not working on such extreme workloads, Threadripper Pro goes all the way down to 16 cores, right?
Mhm.
So you get that span, and that's the other thing that a lot of our enterprise customers like is they can deploy one chassis. They know that it's air cooled, it's relatively small for the power it delivers, and you can deploy it in multiple different configurations, right? You have one platform to manage just different core counts on the platforms, and that's something people didn't have before.
yeah, well, because there's, yeah, like you said, there's certain workflows where it just doesn't even make sense. You know, if you're putting together like a GPU render node, no, you don't need 64 cores. So you can toss in one of the, you know, 24 core or something like that. You just got to have enough power to feed everything. But that's where the, you know, the rest of the platform itself, the PCIe lanes, the memory bandwidth, you know, that comes into a factor. But yeah, you save a little bit of money on the CPU because it's going to be idle because it's doing a very specific job.
Yeah, for some GPU renderers, I think that's something we'll see change as well, right? I mean, if you look at Redshift today, right? Redshift is a renderer, it's a GPU renderer, but you have to have a host processor anyway, whether you're talking about a workstation or in the data center in a server. Really, you want your renderer to use the CPU and the GPU together. I mean, even you got 24 cores. A 24 core Threadripper Pro is a speedy little device. So you want a renderer that can do both, you know, that can take advantage of both, and you don't even have to render in the same scene. You could be using V-Ray CPU on your CPU to render one scene while you're rendering other scenes and other frames from those scenes on the GPUs in the same chassis.
Ooh, cool.
You may as well take advantage of all of that power that's in the system.
Yeah.
And again, you know, there's more than enough memory bandwidth in a Threadripper Pro to feed the GPUs and feed the CPU at the same time. It's designed to have that balance and give everything you need for every workload you want.
Because Kelly, is it V-Ray that can do both at the same
V-Ray
time?
does both right now.
Yeah.
I do want to grab this question from YouTube since we're kind of on the topic of GPU acceleration a little bit. In Biggin on YouTube asks, with rendering, encoding, and AI using or shifting to GPU acceleration, is there a need to keep adding cores, or could we see a contraction back to lower counts and higher clocks on the CPU side?
That's a very good question, actually, and I'm afraid the answer is a little bit complicated, but let me see if I can break it down a little bit. When we look at rendering, and I've had discussions with the folks at Chaos Group about this and other rendering vendors as well, what they find is the more your light is bouncing around the scene, the more divergent the light rays get in the scene, the more the tipping point, the balance of which type of processor is faster goes back to the CPU. So in any case, you're likely to get similar performance from a 64-core Threadripper Pro as a very high-end graphics card today on the average scene. But then for certain scenes, the GPU really starts to break down in its performance. And it's not that the GPU is not a very good accelerator. You know, GPUs are very good at accelerating particular types of workload. But the moment those workloads diverge from being, oh, we can do everything in parallel at once in the similar sort of direction, and you start breaking down again, you have light rays bouncing around in different places in the scene. Then it goes back and the CPU becomes the star. And for the most part, you can just use both together. The other thing that's still the case is when you're doing GPU rendering and you run out of memory on your GPU to hold your data structures and your textures, well, performance drops off the cliff, right?
Yeah.
And the CPU with a terabyte of memory, even for some of the most complex scenes done by companies like Pixar or other large visual effects houses, terabyte of memory is enough to hold the whole thing in memory. And then your CPU can do it. And I think that's why you see the big studios are still using CPUs for their rendering, because they need that memory capacity. When it comes to AI, I think it depends what sort of AI you're doing. You have overhead of getting your data down to the graphics processor to go perform the inference on it. And some inference is better done on the CPU. In general, GPUs are really excellent for AI, and that's probably a trend there. And then as far as encoding goes, it's a little bit of a similar story. You get flexibility of the CPU. The accelerators that exist on the GPU for doing encoding, once you've built them, you can't go and tweak them, right? So if you want to change your encoder design, or say, oh, well, actually, we've discovered for a certain type of video, or maybe it's a certain type of HDR video, we wish we were doing the encoding a different way. Now you're looking at maybe 3 or 4 years before you can bring that change about. Whereas on the CPU, I mean, there's an explosion in encoder vendors, software vendors today. And that's not a surprise, because the amount of streaming online and the need to deliver more content more quickly. We're seeing a lot of experimentation, really to try and get the best bit rate based on perceptual differences. And these different companies have different models for how they decide, is encoding A or encoding B the best encoding here? And when you put that into a hardware accelerator you designed 3 years ago, you're stuck with what you thought then. But actually, in a lot of cases, maybe there's a new way to think about this. And for the streaming providers in particular, the people who are streaming millions of streams an hour, even a 2% saving on bit rate is massive, right? And so for those class of users, the trade-off says, hey, let's keep the flexibility and the ability to tweak things a little bit more, plus the general purpose nature of the CPU rather than just doing the GPU. So hopefully
GPU encoding too, it's fairly bare bones. I mean, it doesn't have to be, but like what they're making it for, it feels like they're making it for people doing like live streams. Like we can take advantage of it in Premiere Pro, but like it doesn't support things like 2-pass encoding. Oftentimes the quality isn't quite as good at the same bit rate. So if you're looking for the best video quality at the smallest file size, you go back to using software encoding, done on the CPU versus on the GPU.
Yeah, no, exactly. And as I said, though, in video codecs, it's a very fast changing landscape. We're just seeing AV1 hardware encoding and decoding show up in silicon, but the industry is already talking about AV2, right? So, the industry's moved on because everyone wants, So that there's always going to be this lag, and there'll always be the newer, better thing. Yes,
you're right. Like CPU is just flexible. It's true for encoding. It's true for AI, like you're talking about before. Like you run to the same memory limits with AI. I know there's a lot of talk about like, well, hey, with CPU you can take advantage of AVX, AVX2 and AVX 512 and all those other instruction sets. If you need better precision and all that kind of jazz, a lot of GPUs will not have very good double precision performance. You got to get up to the workstation class GPUs, and those things are expensive. So I know a lot of people, they end up just using the consumer GPUs for the single precision stuff, and anything double precision they got to do, they do on a CPU, because you can get pretty darn good performance, on CPUs these days, even for those things that are not really traditionally, but recently done more on the GPU.
Right. Yeah, no, that's true. Hey, I saw another comment here that's pretty funny. Somebody said, the issue is I'm single-threaded. I'm not sure. I think he's saying, I'm not sure I can use all those applications at the same time. And, the other thing we see our customers doing a lot is, especially if you look at the studios, they say, well, there are no workstations really. There are render farm nodes that are being borrowed by artists during the day. And that's the other thing you see too. It's like there's always somebody in your company who needs the extra performance. And if you've got 32 or 64 cores and you don't need them all right now, or you can just sign them over to the render farm and they'll still be used. You won't notice it.
Ooh, that's cool.
Because the system is more than enough performance, right? You can help out people, and when the studio's in a crunch time and maybe something went wrong and they had to go back and rework an effect, and well, we've only got 2 days left to deliver this. You've got that extra performance on tap, and that reminds me of that reminds me of the other thing too that we found with some users is the thing that they like about having the core count and the performance there is. Something always goes wrong in a project, right? But you've got a deadline. You have to make that delivery at 5 o'clock next Friday. They know that they could still be working on their project right up until Thursday night. And when they hit render, they have enough performance there to get them through and make sure they deliver on time, right? Maybe they're not using that performance all the time, but that crunch time comes, and it comes always to all of us. They know that they can rely on the processor to get them through it and deliver on time. And sometimes it's just nice to know that you have that safety cushion.
Well, yeah, I mean, and that's not even like a unique thing to computers. I mean, I do that with like tools, in my garage. There's a lot of tools out there that I do not use, like not 99% of the time. But man, when I need that one thing because I'm doing something, yeah, I need that. Or same with like people who really enjoy cooking. Like. Do you need your oven to be able to? Okay, I'm not a cook, so this is probably in general. But do you need that 6-burner stove? Like, no, most of the time, no. But hey, on Thanksgiving, yeah,
right. No, and I'm a software engineer by trade, and I can't. It's hard to even think about the level of performance that I had when I first started doing that as my profession. But one of the things as a software engineer in the old days, you always had to think about is. Well, I'm really trying to fix this, or I'm trying to make this change. I can't change that one thing over there because if I change that thing over there, I have to rebuild the entire piece of software, and that's going to take an hour, right? So then you find yourself changing what you're doing and changing the way you work to work around this limitation that if you do that, you're out of luck for an hour, right? And this is the old days. There was no internet. What are you going to do with yourself for an hour while your computer is being consumed by everything else? You just avoid it at all costs. So the same thing happens to software engineers here. We have some very large companies using Threadripper Pro for all of their software developers and deploying thousands upon thousands of Threadripper Pros for their software engineers because they know it means they're not going to have to work around the capability of their system, or they're not going to have a server room full of a compile farm just to serve people. When those software engineers, whatever it is they need to do, they always have the power there on tap, right? And maybe it's only twice a week, but twice a week is a lot, and 2 hours out of that week waiting for the compile to complete, you don't want to have to deal with that, right?
Yeah, I mean, people are expensive. Computers compared to like the people cost, computers are nothing. But I mean, yeah, like you look at that sticker shock, like you can buy, you can buy a $10,000 computer, and to a lot of people, that's a lot of money. But when you're paying people hundreds of dollars an hour, that pays for itself very quickly. I mean, I know we have a number of customers who they tell us like, hey, once we can get 10%, let us know, and like, well, we're going to replace our fleet because to them, it's a fixed cost that just pays dividends.
Well, I've often had that discussion with our virtual production, any other customers that come to our sales with virtual production, that so they're looking at 4 nodes to run a giant LED wall, and they're going to have, the production system that's up front that's controlling things, and there's a bunch of computers going on. Like, well, can we save some money and just do Ryzen and the LED wall nodes, because they're just going to be sitting there. Doesn't matter for FPS. And well, keep in mind, you can network those all together. And if you need to rebuild your lighting, they will all work together, and you have all those threads rebuilding that lighting. And now you have your cast and crew waiting for lighting to be rebuilt. how much money are you spending waiting versus
Exactly.
putting a Threadripper or Threadripper Pro into these walls and just cranking that out in minutes, you know?
No, that's exactly right. Right. You don't want your technology telling you what artistic decisions to make.
Yeah, and I really like the fact that we can do that now, where before, if you needed a lot of computing power, you had to either use the cloud or you had a big old server closet. And the fact now that just distribute that throughout the office or throughout all these other all these systems out there, and they can communicate. I mean, obviously the software has to support it, but as long as you got software support for that, like, to me, that seems awesome, because that gives you a lot more redundancy too. Like, same thing in like a server room. If one of your nodes goes down, it spreads across the others. But now the same thing. You can just have everyone on their own workstations, and then it can just take over whatever it needs, and like, that's awesome.
For Unreal, it's all built in, because that's the way the workflow's always been. To like, when everyone goes home for the day, we're gonna crunch some stuff overnight on every computer that's in this studio because no one's using it right now, and we need it. So it's been built in forever and works well.
It's so cool.
The old answer to that used to be, oh, well, let's just rent some cloud servers. Right? we need extra processing that's going to rent cloud servers, and I think Threadripper Pro really changed that value equation. Now it definitely still varies from company to company, and they may have other reasons why they want to put compute resources in the cloud. But you have to take a lot harder look at what the costs really are. And for a lot of people, they find that it's much cheaper to put a 64-core or 32-core processor on a desk-side workstation than when you look at and say, well, we need 2 years of cloud compute resource at this much.
Yeah,
it's not quite the same anymore.
Yeah, I see that a lot with editing in the cloud. It seems to be kind of a buzz thing. It hasn't, maybe not this year, but in previous years, because I think people have started to realize that, okay, yeah, it looks like it's cheap, but man, when you actually price it out over the cost over a year, it's like $6,000 per person. It's like, oh, we could just buy a new computer every year and get the latest gen, or whatever. And also, the other part that's difficult with cloud is you've got to get the data wherever you're doing the processing. I'm more on the the editing side than the game data, but I'm sure it's similar. We're like, man, people might have like a 10 terabyte project, a whole bunch of like Red 8K footage. Like, it can be huge. And how do you get it to those data centers? And like, it's funny. The answer is you put it into an external drive and you mail it, and they copy it. But like, that means that you have to wait. Even if you overnight it, that's going to be a couple of days before you can start actually doing anything. And the fact now that you can actually just sit down and do stuff. Like, I was doing a little bit of poking around this morning, just in prep for the stream, and I decided to throw some Red 8K onto one of the Threadripper Pro systems we have, because a couple of years ago, like, that was a huge demo, like showing like, hey, we can do Red 8K without proxies, but like, it was borderline. If you did too much, you'd be dropping frames. But now, like, I just threw it on, I just hit go, and like, it just worked. Like, I could go up to 2x speed, 3x speed, and the fact that, again, you can do that immediately. You don't have to worry about transcoding, making proxies, doing anything else. You can just, as soon as you've got the files on your computer, you can start working. Like, that too is huge to me. It just gets your computer out of the way of your workflow and just lets you just go, just do things.
Right. No, that brings back a fond memory for me, because before we released the Threadripper 3, the Threadripper Pro, we went and did a little tour, and we had some secret demo rooms at a couple of big industry conferences, and we brought by partners. And one day, it was in Europe actually, we brought by the nice folks from Red, who are a great partner for AMD, and we just said, hey, here's the computer. Put whatever you want on it, try whatever you want. And the look on their face when they saw that they could play back 8K Red Raw without a GPU accelerator, because they'd written that CUDA accelerator. You can't unsee that look. They that look on their face, like, the future is here, right? They didn't believe that they would get to that point. Those are definitely the more fun parts of my job, moments like that.
Yeah, because it's always interesting, because I think a lot of times, especially on these like heavier products with higher core counts and stuff, people tend to focus on tasks where you like hit go and then you've got to wait. It's like, yeah, we went from 10 minutes to 2 minutes, and like, yeah, that's awesome. Obviously, that's awesome. But to me, it's a lot more of the stuff where someone is working, like sitting there at a computer, they hit something and they got to wait for something on the screen. Those like active kind of things. To me, that's the bigger deal. Once you can do this stuff like editing things, real time, to me, that is a much bigger impact on someone's workflow, because those things that are highly threaded, you can brute force. I mean, we've talked about like, distributing across nodes. Oftentimes it's just, hey, that's my coffee break. That's my lunch break. That's overnight. They're just used to that already. But those things where you are waiting on the computer, that's where this kind of stuff I feel is the most groundbreaking.
Yeah, and that's where we'll start to see what I like to think of as the second wave of Threadripper performance. The first wave of Threadripper performance was just, here it is, run whatever you want, and look how great it is. Now we've done that part. Now we've moved on to the second wave, and the second wave is, well, what happens if you start optimizing software to do this? A good example of that, by the way, is the work that we did in collaboration with ANSYS to bring AMD's AOCL libraries, our math compute libraries, to their software package, and to take advantage of libraries that are hand-tuned for the Threadripper Pro and the EPYC architectures. And in that case, for some of their benchmark tests, and ANSYS have a number of benchmarks, we were seeing a 2x increase in performance just from taking what you did, what you had already, and saying, hey, let's do a little tuning for the platform. And we'll see more of that happening over the next 12 and 18 months. I think you'll see a lot more software vendors come out and say, oh, look, here, we've got a boost here, we've got a boost there. Another good example of that is, Autodesk with the Arnold, with the 6.04 release that they did, they got some major boosts in performance. And that came when we delivered a Threadripper Pro system to one of their lead engineers and said, hey, what do you think? And you start looking at it and say, well, hang on a minute, I think I can adjust a few things. And before you know it, here's a small performance boost for all platforms with Arnold, but on the 64-core and the 32-core processors, you just see this massive jump, right? That's the wave we're in now. It can only get better than it is today, right? And it's really free performance. Somebody already bought Threadripper Pro for the performance it delivers them today, and we're just bringing extra performance on top of that with these new software releases. And it won't just be that sort of tuning, but again, now you have this number of threads. Now you can start multi-threading workloads that previously you said it never would make sense. So we're looking at some aspects of CAD performance, for example, where the old wisdom was, no, you can't multi-thread that.
Yeah.
But then we've done the work, and we have some CAD experts on my team, and we've done the work and said, oh no, look, we did this multi-threaded, and look what a difference it makes. And maybe you should think about that. And not just on Threadripper Pro, by the way, but all the way down to 8-core notebooks. There are a lot of Ryzen notebooks with 8 cores in there that are very good as well. So they can leverage some of those gains for the users who are stuck with notebooks or need to be portable. But when you put the 64 cores behind it, you're going to see a big jump. And I think that goes to your point, Matt. It's some of those operations, by the way, we're seeing opportunities where things that take 500 milliseconds, half a second, you can go spin up 64 cores, work on something for half a second, and spin the cores down and deliver performance gains, right? And that's the sort of thing that in the past, you're right, people were thinking about multi-threaded CPUs as the big batch job, the thing I want to run overnight. But with the architecture that we have and with the core count we have, now you can spin things up for very short workloads and bring extra productivity to every click that you're doing.
Ooh, that's pretty cool. Yeah. Since we have a bit of a moment, I want to grab this question. It's kind of a future-looking one, so I don't know how much of an answer. Ethelbrook Coyote asks, so we're talking about Threadripper. What's going on right now with the platform? Maybe the guest cannot answer that, but there's not been an update and no real messaging as to why the delay.
It's always tricky when dealing with future-looking questions. I think the thing that I can say confidently is the Threadripper Pro platform is not going away, right? We're committed. We know that we have users who love these platforms and they love the core counts and everything else the processors are bringing to them. And you will continue to see high core count desktop processors from us in the future.
I mean, I'm sure it's one of those things where the whole industry's been hit with delays due to supply chain and all kinds of stuff. So, I mean, the fact that we've shipped anything is been amazing.
Well, and I've heard reports too that you know, the big silicon manufacturers, their complete capacity is like bought out for the next like 2 years to like 2023. Like they're crunching out chips as fast as they possibly can, and there's really nothing more you can do about it.
Yeah, I think it's safe to say that Threadripper Pro today has so much performance that you know, people always want to talk. People always want to talk about the next thing, but what you have today is going to change your life if you're not using it already, right? So
I want to show Matt's graph that he's got hiding behind here. This is crazy good.
I wasn't sure if we were going to use this or not. Yeah,
just to show, I just show to Chris's point what we're talking about.
Yeah, so I was curious this morning, so I just looked up in our benchmark database, and I think the V-Ray Next is from the V-Ray's actual database. So I was just looking at lightly threaded applications like Photoshop and After Effects, just each generation of Threadripper. So this isn't Threadripper Pro. I just kept it Threadripper because we actually have multiple generations. And so, like, what was cool was a single or lightly threaded application. First gen and second gen Threadripper were about the same, but you go up to third gen, and we saw a big old increase, and that was such a cool thing. We talked about that a little bit near the beginning of the stream, where the current gen Threadripper and Threadripper Pro, one of the really nice things about them is you don't have to sacrifice, performance in applications like Photoshop in order to get better performance in things like Cinebench. So that's really cool, but also the more heavily threaded applications. So the blue and the orange here are CPU rendering. So like for a lot of people, this is kind of theoretical. For the people actually doing that, obviously it makes perfect sense, and it's directly applicable. The gray here is the new version of After Effects, where they greatly improved multi-frame performance, so you get much better performance. But what was cool there is like first gen Threadripper to second gen was more than a 50% increase. A lot of that, we had a doubling in core count, first gen to second gen. But then second gen to third gen, we again had a doubling. But that saw way more than, that was up to, almost 4.5 times performance over first gen Threadripper. So that's what we're kind of seeing right now. Now, I'm sure we don't know what the next gen Threadripper or Threadripper Pro is. We have to wait until we actually, have it and we can test it and everything. But I don't know if we can continue at this trajectory, but we'll see. But like what Chris was saying, there's always going to be something else around the corner. So that's always the really hard thing, and sometimes that something's going to be coming, in a month. Sometimes there's announcements and in those cases, maybe wait and see. But if you don't know when the next thing is going to be coming, you don't know what the performance is going to be, the better performance you get today is always going to be more beneficial than something in the future, because it just adds up over time.
No, imagine what you could do with the extra time you get if you have if you have a Threadripper Pro for the next 2 months, right? Yeah. You have it now, what you can do in the next 2 months. And I think that's true for a lot of the people who buy Threadripper Pro. What they have today, it's such a difference to what they had before that it's just worth it to buy it now, because you need it now. It's not like you're planning a project that, it's not like you're planning a project a year from now and you're thinking, well, should I buy the computer now? No, you're buying it because you need it today, and you will make money with it today.
Yeah, that's the thing.
I saw. Go ahead. I was going to say I saw a follow-on question to that. What caused the single-threaded, lightly threaded jump on the third generation? Well, there are a couple things. The first one is with the Zen 2 core, we saw a really significant increase in IPC. The IPC, instructions per cycle and sessions per clock, that measure of efficiency of the processor. And that is a major contributor there. And then the second thing is with this generation of Threadripper, our single-threaded frequencies are generally a lot higher than they were in the previous generation. That's something we were able to achieve. And so when you combine those two things together, that's where you get the extra performance from there.
Yeah, and it was big. Like I remember with first and second gen Threadripper, it was just you always had to make that choice. Like what part of your workflow is more important to you? The lightly threaded stuff, the multi-threaded stuff, and just not having to make that choice anymore. Like Chris, you mentioned before, there's still going to be places where like Ryzen is going to be better because like if all you do is Photoshop, you're probably going to go Ryzen because like it's going to be a little bit faster. But how many people are actually limited by performance in Photoshop? It's not really that many.
Well, but that part is true. But I would say, Matt, we know from talking to our friends at Adobe, I would say, you might consider yourself a very sophisticated Photoshop user, but imagine a document with 1,000 layers.
Mm-hmm.
Ooh,
and imagine how much memory that consumes.
Yeah.
You need a Threadripper. You need the Threadripper Pro. You need the memory bandwidth as well and the memory capacity, right? There are people out there doing things with Photoshop that we just can't even think about, right? Imagine somebody building a matte background for a movie and how big that image is. And again, and I was shocked to hear this, right? Think of 1,000 layers on your Photoshop document.
How do you find the one you want to edit?
wow.
I mean, I'm always amazed at how far people push tools, to be honest. Like, you still hear about people using Excel to do, like, weather simulations. It's like, what are you doing?
Actually, I'm glad you brought that up. That reminds me, Excel has a lot of multi-threading in it. And there are many, for very large spreadsheets, there are a lot of operations in Excel that scale all the way up to the 64 cores of a Threadripper Pro. And that, again, you don't think about that, right? You don't think about Excel as being this multi-threaded thing, but actually there's a lot of Excel workloads. Again, you said people pushing their tools. I would almost say they're abusing their tools. Like, well, hey, guess what? Guess what I can do in Excel?
Right.
Should you really be doing it in Excel? That's a separate question. But if you are doing that, let's try it on the Threadripper Pro and see how much extra performance you get.
It was funny. A couple of years ago, I think we had a customer reach out that like wanted some custom testing for Excel, and we're like, why do you need testing for Excel? It's just Excel. And then once they like showed us what they're doing, we're like, oh, okay. So yeah, you need something different than just a standard PC.
Yeah, wasn't it like a 50 or 100 gig Excel file or something? Just like what?
Yeah.
How do you even get that much data into? I mean,
I kind of had the same experience with Unreal because I came from a game dev background. And so that's kind of like the mentality I had. Then I started working with these virtual production people, and so many of them were buying A6000s just for VRAM. Like that's the only thing they needed. Like they just need more VRAM than what was available on GeForce. And so like I see the same thing is possible with CPUs. Like people are going to be buying Threadripper Pro just because they need the RAM. Like there's no else to get that much RAM.
Yeah, and by the way, it's a very cost-effective way to get that RAM, right? So,
sure.
You end up, again, in some of those cases, you end up spending far more on memory than you spend on your processor. And that's the other thing that some people don't think about, right? You look at if you just look at the chip and you say, oh, well, that 64-core processor, that's a big price jump. But by the time you put the chip in a chassis with a bunch of disks, you put a $5,000 graphics card in there, and you put 0.5 terabyte of memory, all of a sudden that incremental extra to get the 32 cores, as a percentage of the system price, it's not actually that high.
Yeah.
And I'm a software engineering guy. I'm not a marketing guy or a sales guy, but boy, I wish we could get the kind of prices for processors that people are willing to pay for GPUs these days.
Oh yeah.
I feel like if we price Threadripper Pro like people price GPUs, you'd be paying $25,000 for your processor. Oh wait, I think that was what the other guys used to do back in the day with Xeon. So.
I was gonna say, wasn't it like Xeon W Gold was like $12,000 or something?
I remember when I first started at Puget, watching Houston having to build quad socket systems for customers that just needed RAM. Like that was the reason.
Because there's the only way to get like 2 terabytes.
Yeah.
Those things max out. That's
Now it's like
Yeah.
Threadripper Pro can get you one by itself and at a fraction of the cost and way better stability and ease of use. And
Would have to put a giant radiator on the side.
oh man.
had a custom drill at the chassis to make the boards fit and stuff.
And one AIO for each proc. It was $70,000 machine.
Yeah, no,
Yeah, the fact
we've
that you can
seen
just do
cases
that
like
now
that.
is
Yeah, and we've seen cases like that. You know, another application I think that works really well on the Threadripper Pro platform is Flame, right? And people who need Flame, right? But Flame comes with, well, these are all the PCI Express cards you need to plug in, and you need a certain amount of memory to work with Flame, and you need the graphics cards together. And again, that's the case where before you might be buying a dual socket platform just to have the expandability and the memory that you needed. You didn't need anything else from it. And again, with Threadripper Pro, because you have high core count processors and low core count processors all in the same form factor, you don't have to buy things that you really don't need.
Yeah. Well, that's one thing I do not miss at all is a dual socket and quad socket, because we've largely, I don't even know if we have a product offering anymore, even for like dual Xeon. I mean, back in the day we were doing dual Opteron and all those things too, but I really, really, really like that we can do everything single socket now, because dual socket just had a lot of weird hiccups. With different things, it's always going to be louder. The power supplies always had to be bigger. The boards were huge, more points of failure. You had to, the whole QPI, you had to move data across the bus from one CPU to another. Just everything being on one CPU, all the PCIe lanes, all of everything is so much cleaner. It's so much easier. It's so much cheaper. Just everything is better.
Yeah.
Let's see. Other questions there, I'm waiting. I haven't seen the question, by the way, and I couldn't answer the question even if it came up. But some people ask us, when are we going to produce a Threadripper for mobile, right? Like, can you imagine a 64 core processor in a mobile form factor? But I certainly can't comment or even think about 64 cores in a mobile processor. But Threadripper Pro is pretty portable. You may not be able to open it up on your laptop, on your lap, on a plane, but there's nothing to stop you carrying it around.
Yeah,
I mean, I'm sure it's only a matter of time before that is a thing. So,
I mean,
has anyone made a micro ATX Threadripper Pro board? That's what I want. I want a micro ATX Threadripper Pro. That'd be awesome.
I thought
that
ASRock
is pretty extreme.
ASRock always does crazy things like that, so I wouldn't be surprised.
Because that's the size where you could get it down to aircraft carry-on size.
That's true. Yeah. When the size of your chassis is only determined by the cooler that you put in, right? Well, that and memory. I mean, that is the one thing. If you want a big memory capacity, you need lots of DIMM slots, and that's going to be the thing that drives your motherboard size almost more than the CPU socket.
Mm-hmm. Yeah, ASRock has a MATX, but it only has 4 DIMM slots.
I mean, still, aren't there 512 gig Reg CC? Technically,
we're gonna make it happen.
Well, but hey, give it like 10 years, and like your laptop will have the same performance as today's Threadripper Pro. I mean, that's the cool thing about performance over time. Like, we look back right now and like what we can do in a small box, with Threadripper Pro or whatever. Before, that was a closet of hardware. Like that was multiple server nodes. So that's just insane to me how fast things.
Well,
they seem like they seem like they change slow when you're looking at it like one gen to the next, 1 month to the next. But when you actually look back over the years, that's where you're just like, oh.
That's true. And imagine what a Threadripper Pro could look like 10 years from now.
Oh, right.
Yeah. And how much power, back when I did a lot more in graphics, somebody asked me, well, isn't graphics good enough already? And I said, well, if you want to approximate, if you want to represent reality, just go sit on a beach somewhere and become aware of the individual grains of sand that are blowing across the beach and everything, just how much there is to reality. Everything we're doing today is an approximation, right? So we need that extra power. We need that 10 years of processing growth just to start bringing more and more of reality in.
For sure.
Exciting.
I remember when I was working in a game studio, I had a producer tell us one time that, like, I don't know why you need, like, because there's a new generation coming out, and he's like, I don't know why you would need more polygons put in the scene because we can just do everything with normal maps. I'm like, no, if you give me polygons, we're going to use all the polygons we have. Like, it doesn't matter what the limit is. We'll find a way to use them all.
Yeah. And, by the way, Kelly, you did bring up, it's not really a downside, but one of the joking complaints we've had from some Threadripper Pro companies with Threadripper Pros on artist desktops, those artists are working with models that are so complex now, and they forget that maybe the server farm hasn't caught up yet. So they're working with that because they can, right? They, in fact, they don't even notice that they're working with models that complex. But then somebody has to go do the work to make it simpler, just to be able to go run it on the farm and generate the frames.
That's funny.
We're giving. I didn't think I would say this, but maybe we're giving artists too much power. Maybe artists want less power.
Right.
The server room needs more power.
Yeah.
Yeah, when I was developing for Xbox, I had the scene running great on my PC, but then when I pushed it to the Xbox, it just shrugged to like 5 frames per second. I was like, oh, I guess I have to be more mindful of what I'm doing with my lights.
Yeah, exactly.
All right, so did those bring us to just a touch over our
geez.
hour? Yeah, we knocked that out real fast. Great. Is there anything else you'd like to talk about or mention before we wrap up, Chris?
No, I want to thank you guys for having me today. I always like talking about, Threadripper Pro and people in the media and entertainment industry who are using it and things they do with it are some of my favorite things to talk about all the time. It's the part where my wife just, please, can you stop talking about work? But it's so amazing, and we're really fortunate to have Puget Systems as a partner, helping us get our technology in the hands of users, and again, then seeing what our users do with it, and really bring innovation, new technologies, and new experiences to the world in general. That's what make this job fun.
Yeah, I'm endlessly amazed at what people are doing with and how accessible this power is to like individuals. Even it's incredible. I dig it so much. I'm so excited for the future. It's great. We're in great times.
There's other things about today that aren't so great, but technology.
Yeah. So thank you, Chris, for taking time out of your day to join us, and Matt and Kelly as well, and you as well, the audience, for joining us. I'll do my normal outro. We do this every Wednesday for the most like 99% of Wednesdays, 1 p.m. Pacific, where we bring in outside experts like Chris or other video editors and VFX artists and 3D designers and all kinds of stuff to talk about what they do and how they do it, and the crossover of the technology and software. And so mark your calendars, tell your friends, 1 p.m. Pacific, Wednesdays, right here, YouTube and Twitch. And we'll see you next time. Bye.
Thanks, guys.